Hello and welcome to the next in a short series of videos about topics in analog electronics and physics. This time starting off with electric and magnetic fields. And the first thing I need to talk about is vectors, scalars, vector fields and scalar fields. So we'll start at the beginning. What is a vector? I don't think I can put it any better than this.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Well, I could probably have put it rather less enthusiastically, but hopefully you get the idea. A vector is a quantity with magnitude and direction. And that's opposed to a scalar. A scalar is a quantity that just has magnitude but does not have direction. Some examples will no doubt help. Consider this pen. This pen has mass. However, the mass doesn't have a direction. Asking in which direction does the mass of this pen point is meaningless. It's just an innate property of the pen itself. That makes mass a scalar. Also, the mass of this pen doesn't depend on where the pen is. It has exactly the same mass no matter where it was in the universe. That would be constant. And that suggests that mass is not a field. It's not a function of position. Compare that with the temperature. Temperature is also a scalar because it doesn't have a direction. Saying that the temperature is 18 degrees is fine. Asking in which direction is the temperature 18 degrees makes no sense. So temperature is a scalar. However, if you plot the temperature against location, you'll find that it changes. So the temperature is a function of where you are. That makes temperature a field, a scalar field. We're using the word field in a particular mathematical sense here to imply a volume of space in which a quantity takes a particular value. In this case, the temperature has a particular value somewhere in the atmosphere. There is no direction to the temperature, so temperature is a scalar field. Now, let's consider a vector. While mass is a scalar, weight is a vector, because weight is a force. Weight acts in a particular direction, the direction in which the pen would move if I let go. In this case, down. So weight is a vector. Weight is also a function of where you are. While the mass of the pen is constant, its weight depends on where in the universe it is. If it was on the moon, there would be a much smaller force pushing it down. It would have a lower weight. If it was just in the middle of outer space somewhere, it may be weightless and have no weight at all. So the weight is a function of where you are. And that makes weight a vector field. It has a magnitude and a direction, and the magnitude and direction are a function of where it is in space. Right. A few more examples, and a quick test. Which one of these pairs contains one scalar field and one vector field? pause the video here if you need a little bit of extra time to think about this. Okay, I'll start going through them. It might be instructive if I go through them and divide up all of these 10 quantities into the 4 possible categories. They can either be vectors or scalars, and they can either be fields or just have constant values. Fields would mean that the value is a function of where they are. Constants, the value is just a constant. Doesn't depend on where they are. So here we have vector constants, here scalar constants, scalar fields, vector fields. Let's try and assign each of these 10 things into one of these 4 categories. We'll start with density. Well, density is a scalar. It doesn't have a direction. Density is measured in kilograms per cubic meter. It's the amount of mass in unit volume. That's a scalar. But it does depend on where you are. Unless you're talking about a totally uniform object, it's going to have more mass in some places than it has in other places. So I would argue that density is a scalar field. I'll put it in here. Next, charge. Charge is like mass. If an object has a charge, it will have that charge no matter where in the universe it is. And charge, just like mass, doesn't have a direction. So that puts charge up here. Charge is a scalar constant. Force. Well, force is a vector. It has a direction. But just force by itself isn't necessarily a function of position. If all you're told is that the force is 10 newtons, that contains no information that the force is going to change in different places. So I would say that force, if you're just told about force, is a constant vector. Velocity. Velocity is a vector because velocity has a particular direction, the direction in which you're going. But again, if you're just told that the velocity is 2 meters per second, that's not a function of where you are. So I would put velocity up here as well. Wind velocity, however. Now we're being told what the velocity is. And wind is a function of position. Some places in the atmosphere there is a lot of wind, in other places there is no wind, in some places you have whirlwinds, in which you have the wind going in one direction in one place and in the opposite direction in the other place. So wind velocity is a field. And it's a vector field because velocity is a vector. So wind velocity I'd put down here. Atmospheric pressure. Atmospheric pressure is a scalar because the atmosphere acts like a fluid. And in a fluid, the pressure presses out in all directions, just like the water did in a pipe. So atmospheric pressure is a scalar, but it's a function of position. You have areas of high pressure and areas of low pressure. So I'd say that makes atmospheric pressure a scalar field. Voltage. Well, voltage is a scalar. It doesn't have direction. It's just a property of one particular point in the circuit. It is the analogy of pressure in the hydraulic analogy. But it is a function of position. As you go round a circuit, the voltage changes. So that, I would say, scalar field. Energy. Energy is a scalar. And if you're just told that an object has an energy of 10 joules, there's no information there to say that that energy is going to change if the object moves in position. So I would say energy, constant scalar. Mass. Well, mass, as we've seen, doesn't change with position, and it has no direction, so it's a scalar. So mass, constant scalar. Acceleration. Acceleration is a vector. It has a direction. But there's nothing here telling you that the acceleration is a function of position, so I would put it up here. Constant vector. Which one of those pairs has a scalar field and a vector field? Well, those two. That's the only pair in which one is a scalar field and the other one is a vector field. So I would say, correct answer, C. Wind velocity and atmospheric pressure. Okay, that's the end of the first introduction chat. Next time we're going to have a look in more detail at gravity, because gravity is a very familiar force, and we can use that to gain a good understanding of what we mean by potential. And that is an important concept in electronics.